Welcome to Brain Vision.
Okay. An amphoteric substance is one that can act as an acid or a base. So when we look at H2O and H2PO4 with a negative charge, okay, both of these compounds have hydrogen, which means they can act as an acid, and they're both capable of acting as bases as well. So when we look at the structure of water, it does have lone pairs of electrons on the oxygens, which allows it to accept hydrogen ions and act as a base. The H2PO4 has that negative charge, which also makes it likely to accept hydrogen ions, which are positive, again, acting as a base. Now, to compare these two or look at these two, we can actually look at them reacting together since they are both amphoteric. Right? We could also look at this in terms of them reacting with another acid or a different base, but this way we can actually see both of these together. So if we look at this as a first example, if we treat water as the acid and H2PO4 is the base, right? So since they can both act both ways, it doesn't matter which one we do first. If water acts as an acid, it gives up a hydrogen, okay, hydrogen ion, and gives it to the base. So that means water is left as hydroxide. It loses that hydrogen ion, and H2PO4 gains it as the base. So it becomes H3PO4 with no charge, right? On the flip side, we could also have the reaction happen the opposite way. So if we have water act as the base and H2PO4 act as the acid, right? That's another reaction that can happen. It's just the opposite. So this time the acid gives to the base. If that's the case, that means water is going to gain that hydrogen ion and become the hydronium ion. And the H2PO4 loses a hydrogen, so it becomes HPO4, and then it has a -2 charge because it's lost one more positive charge.